Namaste all, hope you all are doing good. Welcome to Namaste Crypto series. And today we are going to talk about consensus algorithm. And without keeping much suspense, the algorithms that we are going to look into today under consensus algorithm is first is proof of work, and then second is proof of stake. So we are going to understand what is consensus algorithm, and then what is proof of work, and then why do we need it, and all the stuff that is required around proof of work. But finally we are going to end up with what is part in the proof of work and why we need to move on to the next type of algorithm, or the second category, or other types of consensus algorithm. So where we are going to look into proof of stack. Now once we understand the complete picture around proof of stack, we are going to look into what is bad or what is the loophole in the proof of stack. So basically, by the end of this demonstration, you'll get to know consensus algorithm, proof of work, proof of stack, its loopholes, and basically each algorithm has its different flavors and version, which can be customized as per the use case and the requirement. And there is much more work and research is going on to improve these algorithms, followed by new algorithms for the consensus algorithm. So it all begins with the understanding of consensus algorithm. That is what we are going to get started with. So with that mention, let's get started. Consensus algorithm. So what the word means is that everyone needs to be on same page. That is, everyone should agree with one another. So now with the name itself, it makes sense that this is an algorithm, or this is the logic which is applicable where many people, multiple systems, multiple people, or multiple devices, or multiple homogeneous components are working with each other, and everyone needs to be in agreement with each other. That is, everyone needs to be on same page. Everyone should think or come to a common conclusion. So a logic or algorithm which helps us in achieving this target, that everyone should be on same page, everyone should be in agreement with each other. So that kind of logic and that kind of algorithm, we call it as consensus algorithm. So let's take one example of consensus algorithm, which is proof of work. So talking about proof of work, it basically means that show me the evidence that you have completed the work. Show me the evidence that you have actually done the work. Let's say you have not completed the work, but what is the proof that you started the work or you did something? Okay, so the term itself is saying proof of work. Show me that proof that you completed the work. Okay, now let's talk about our context a bit, and then we'll talk about proof of work. So in our context of blockchain, we know it's a decentralized. It means multiple systems are working in different region, on different network, on different devices, and different categories of types of devices, right? So here what is actually that device is doing, okay, that we'll try to understand. So that device is being used by some person, or some person is operating, right? So we'll simply call that person or miner a miner, or we'll simply call that device a miner. So let's see this. We are calling devices as miners, which are working or operated on different networks at different locations, and at different capacity as well. So basically all the parameter values are different, but they all are working towards achieving some common target as part of this blockchain. Okay, now let's take an example here, right? So let's say there is a transaction 1 of $1, transaction 2 of $2, transaction 3 of $4, transaction 4 of $99. Now this is my content, right? And at the bottom we can see there is block 1 of blockchain, block 2 of blockchain, block 3 of blockchain. Now the miners need to validate the content, that T1 $1, T2 $2, is that transaction is possible, is valid, is correct, is good or not. Once the miners validate this, that is they complete the work, that can be considered as a new block, and can be kept it as part of the blockchain by adding a new block. I hope that makes sense. So every new thing is nothing but a content. Now that content is stored as part of one block, and once the miners will try to validate the content, and once the validation is done, they'll consider it as a block and put it on the blockchain. Right, now let's talk in specifics. So there are miner 1, miner 2, miner 3, miner 4, four miners. This is just an example, okay, and we have some content there. So now you know what miners are, right? Some devices which are trying to achieve some concept. some target, right? Now there are four miners which are trying to validate the content, and let's say all four of them were able to successfully validate. Now will I add four blocks because each of them validated that block? Because once someone validates it, it becomes a block and is part of a blockchain. But here there are four miners, so in reality there might be thousands and lakhs of miners. Everyone will validate. Does that mean that I need to put all that duplicates blocks of this content? No, right? So here, to handle that situation, what is happening is, irrespective of whether you solved it or not, but once you solve it, there is one more puzzle that you need to solve. Okay, so let's say in our case, miner 1 was able to validate the content, miner 2 was able to validate the content, miner 3 was also able to validate. Miner 4 is in still progress, so he's out of picture. Miner 1, 2 or 3 completed stage 1, that is validation of the content. Now all those three people needs to solve a puzzle. So what is that puzzle? We'll see about that puzzle in a second. But let's say miner 1, 2, 3, out of those three people who validated the content, miner 1 is the miner who actually solved the puzzle first. So that miner 1 becomes the winner. Now because he became the winner, uh, there would be some, like when we are paying transaction fee because of all the work that is happening in the blockchain, the miner who is the winner will get some commission because of the work that he has done, that is validating. Okay, now once he validates and put into the blockchain successfully, he will receive his award, reward, which is commission. So that is what we can see. The puzzle is solved. Miner 1, 2, 3 validated the content. Miner 1 was able to solve the puzzle first, so he is the winner, and now he is getting the reward, and that block is added as part of the blockchain. I hope the picture is clear. Now let's try to understand what we have learned already. So this puzzle thing, what is that puzzle? So if you remember, in the previous video where we are exploring about what is block and blockchain, we also came across what is nouns and everything. So here the puzzle is, you need to find the nouns of of the content such a way that the output hash should have these many zeros at the beginning. So let's say four zeros at the beginning is the difficulty level, right? Now how that four zeros, five zeros is fixed and all is a different module. But let's say that is a puzzle that you need to uh, update the attribute value, that is the nouns value, such that your content hash plus your nouns hash and the resulting hash, so finally the resultant hash should be such that it should have four zeros in the beginning. Okay, now these four zeros are known as difficulty level, but that can be increased or decreased based on the number of miners or number of traffic that are trying to solve the puzzle. Okay, but in our case, example of puzzle, found nouns is such that hash block has x number of zeros. Now miner 1 was able to find, so he's the winner. He got this, and block was added as part of the blockchain. Everything is done. So this puzzle was something which was helping everyone to come to a consideration that whose block needs to be considered to be kept as part of the blockchain. Okay, so this is one kind of consensus algorithm. Now let's see why this is, what are the loopholes in this consensus algorithm, and then we'll see the next uh, consensus algorithm. Okay, so let's see what is bad in this. Now if we see what is bad in proof of work, first of all, how the puzzle was solved. Puzzle was solved by finding the nouns that is to be generated to achieve the required target, that is four zeros in the resultant hash. Now miner 1 was also trying to do all the variables in the noun such that he comes to the targeted. Miner 2 was also doing, miner 3 was also doing. So here one thing is, everyone was trying to put every possible hash value from the beginning, so that they can come to a targeted value. So there is like unnecessarily every time for every block they are trying from the very beginning. So that is some unnecessary work, not unnecessary but basically not fruitful, or the work which is not adding value, right? So unnecessary computation is getting used. Second is, so miner 1, miner 2, miner 3, all three were trying to, let's say, solve the puzzle, started solving a puzzle at the same time. Now let's say number one miner has more capacity or more power, like is using much uh, computative device is having more computation power compared to miner 2 and miner 3. So in that case, miner 1 is going to win always, because more the GPU and CPU, more the number of hit and trials he can do every second or every comparable unit of time, right? So with this, what happens is the one who is having more computation will try to get the result more quickly. So that means more GPU and more CPU, it means you will have more money. So what does that leads to? So rich people will have more capacity because they'll buy certain devices, right? Or such setup or such devices. So solving and getting rewards, the probability of this mostly goes to the rich people or people having the rich setup. Now, because of this again, the whole concept of blockchain is decentralization, but it is again moving towards the centralization towards people who are rich, and it is consuming more power across the globe because everyone is doing same work. Okay, that is duplication of work. So one is duplication, unnecessary consumption of power, and it is getting centralized towards the rich people because of the computation requirement, right? So because of this, we are moving to the next possible consensus algorithm. It doesn't mean that proof of work is completely gone. No, it will be gone completely only once we have some algorithm which is completely providing the solution and replacing the existing ones. But there are loopholes in the next algorithm also that we are seeing. So it all depends on the use case, but let's keep that discussion aside and move on to the next consensus algorithm. So this algorithm is proof of stake. Proof of work was the first consensus algorithm that we discussed. Now proof of stake is what we are discussing. So here what happens is, unlike the proof of work where I need to set up everything and then I can start mining, here it's not like that. Here, if you are interested in validating, right, you simply deposit some coins. Let's say for example I deposited 10 ethers, which is a big amount, but let's take that for ease of our example. I deposited 10 10 ethers. Okay, and now I'm trying to like I am one of the validator now. So you can see a bunch of people, right? Now I am also became the validator. So basically I am saying, hi blockchain, I am ready to validate a content. Similarly, other people will also deposit and other people will also say that I am also ready, I am also ready, just give me the work whenever you have one. Okay, now that is how we see a bunch of people were formed who we call it as a validator. Now, what blockchain will do is, as soon as some transaction or some work comes, it will choose a validator out of that bunch of people. Okay, let's say we have 100 validators. So, what blockchain did, it chose the 10 people. Okay, now the first one would be the actual validator, but in case of some default or for some reason that the person one was not able to validate, there is a backup validators. Okay, so out of 100, blockchain chose the 10. Now, this is I'm just giving numbers as an example, but the numbers would be different, concept would be same. So there are 100 people. Blockchain said I am choosing these 10 people, and these 10 people are chosen randomly. Okay. Now in this randomly also there is some certainty which we'll discuss in a moment. But as of now, let's consider this. There are 100 people, and blockchain chose 10 people, saying that you 10 are my validators for this content. Now the first validator is the only validator who's going to validate. Only when the first one defaults, the backup validators will come into picture. So in the next step, what we see is we have content, we have validator one as chosen person. Okay, and before proceeding ahead, let's see that we have block one of blockchain, block two of blockchain, block three of blockchain, just like the proof of work. Here also we are trying to confirm a block or confirm a content, making it as a block and put it on the blockchain. So this concept is same, right? So here the validator, what he's doing is he's not mining, we won't say mining here, he's forging or he's creating a new block or he's minting a new block. That is the terms that we use in this algorithm called proof of stake. So here the validator one, which is chosen by the blockchain, will consider the content and he will try to validate and forge a new block. Now once that is confirmed, it's not directly placed into the blockchain. Okay, it will also be confirmed by certain fixed number of validators later on, but he is the main validator. So people, the next validators are not going to validate the content, but they are going to validate that validator 1 has validated the content and whether that is correct or not. So basically validator 1 is going to validate the content, and the other validators who are not the main validators will basically verify that this person has done the work correctly or not. Basically double validation, doubly sure. Okay, now once that is done, the block that is validated by v1 is becoming a confirmed block, and it is kept as part of a blockchain as a new block. Okay, so here if we see that validator 1 is selected, but is he capable or not? So these kind of factors will again come. Okay, so blockchain simply selected out of the validators randomly, but now is he eligible for or not for validating? But we can say he deposited, so he is eligible to validate, right? Why are we questioning that validator again? So here comes the amount. So if he deposited 10 ethers and the transaction comes of 11 ethers, so in case the v1 does something wrong, blockchain has the authority to penalize the validator by providing some penalty, right? So in case the validator 1 is, let's say, he did some fraud, or he intentionally validated that fraud content. Basically he did some fraud in the validating process, so it means he did a fraud of 11 ether. 11 ether, why I'm saying, let's say the transaction is of amount 11 ether, and validator one says that it is valid, but in reality it is not valid. So blockchain, what it needs to do, it needs to punish the validator one, saying that this 11 ether content that you are saying is valid is actually not valid. So you should pay me the $11 because $11, or not $11, it's 11 ether, or some amount which is dependent on the range of or type of contents. But basically the logic is the validator one should get punished. Now when we say is he eligible or not for validating the content, we mean that in case he does the fraud and the blockchain wants to punish him or want to give him the penalty, is he capable, is he or she capable of paying that penalty or not? So that is what we say when we that is what we mean when we say that whether the validator is capable enough or not to validate a specific transaction, right? So in case he is not capable in the beginning itself, we'll say the v1 is not capable, so the backup validator, that is v2 v3, can come and validate, right? So that is what the validators or backup validators are meant for. Now I hope the concept is clear, but let's spend 30 more seconds on this once again. So people interested in validating will deposit and will become a part of this bunch of this group, which is called validators. Now, once some work comes, blockchain will select randomly some group of people, and the first selected person will become the actual validator who will validate the content, and it gets re-verified with other backup validators and other validators, and once confirmed by all, it is kept as a block as part of the blockchain. Now, because of this work, he'll get the commission or reward, the one who did the validate. But in case he does not, or he does the work correctly, or he defaults, basically he was not able to validate, then he is not penalized, but he is left out, and the backup validators will be assigned the work. That is the second point. Third point is v1 is able to validate and he or she validates it, but that is fraud. He validated the incorrect content, saying that this is correct, but in reality that is not correct. So in this case, blockchain has the responsibility to punish or penalize the v1 by charging some amount. Now that amount he or she should be able to pay based on the deposit that they have. Now this is called the capability of the validator. If they are not capable, before the work starts, blockchain can validate that he or she is not capable enough uh, to pay the penalty in case they default. So that's where the capability comes into picture. Now this was the proof of stake. There's one more point that I want to add is, once the work is done and validator says that I don't want to work anymore, I want to go out, I am good. Okay, so in that case the deposited amount along with the amount that the validator have earned throughout this working will be returned to the person's account. Now that is not going to be immediately transferred to the validator's account, but it will take some time, because there is some more works that blockchain needs to do and confirm before it actually transfer it to the validator's account. So that was about proof of stake. Now let's see what bad is in proof of stake. So we saw that it is not expensive to set up, because unlike the proof of work where I need to set up my own device, here they can simply deposit and say that I want to start working. So that is not expensive. And there is a 51% attack which is possible here, but which is possible in theory, but in practical it is not possible because of market cap, because of various factors that we have seen in this algorithm, like backup validators. That is, even when the validators try to fraud, there is other set of validators who will try to double confirm it. So what does this 51% attack means is, let's say all those validators are also friends of this fraud person, so they will also say that this fraudulent content is actually correct. Now altogether they did the fraud. So this is possible, and this is called 51% attack. But what happens is, because market is such divided, or it's not allowing pooling. Okay, so pooling is where people come together and work. It's not allowing that each device is a separate person, will not allow pooling. So here 51% attack is not possible because of the spreading and the avoiding of the concept called pooling. Now the pooling, if you are aware, that is fine, otherwise it doesn't affect us in understanding of this concept. Okay, so here one bad thing that we can see is, if when we said that blockchain can randomly select a validators from the bunch of validators group, we are okay, we say that what is said is done, that is randomly it is selecting, so it is selecting randomly. But there is some factors which are affecting that probability of getting selected. I repeat this again, blockchain selects the validators randomly, but that randomness or that probability is still getting affected by some factors. Let's say some people did more deposit, so probability of getting those selected is more. Okay, that is one thing which is valid also, but it is also again creating cons for the proof of stack algorithm. And there is one more, coinage based selection. So if you are uh, part of that validators for a long time, then there is a bit more probability increase for you compared to the people who came new or who has less age than you. So here age in the sense the duration for which you are part of that validators group. Okay, now this, like this, there are some more few factors as well, but still the proof of stake is considered because it is actually random, only affected by few small factors, but it is not 100% that you deposited more, so you 100% you will get selected. It's not like that, but the probability or randomness does get affected up to some extent. Okay, now there are various flavors and various versions of proof of stake which can be modified and played appropriately as per the requirement of the use case. So that was about what is bad in proof of stake. Now I hope that our capacity to digest is increasing every day, or as we are going across every demonstration, as now we are getting to know each term and we are getting a clear picture about what it is. So next time when we are trying to hear these terms, we are not going to think about the definitions and all, because now we know the proper working, the proper foundation and proper structure around each of these terms. So when we come across some set of collection of terms and we know the meaning and picture of each term, we can easily map and correlate and comes to a conclusion that what is the meaning of that actual sentence or actual programming that we are going to do for even for the investment analysis purpose or the writing of smart contracts and all. So let's not just directly jump into the fire, let's try to understand each term very carefully across this category. Let me know in the comment section if you have any suggestions for any kind of improvement. Let's try to grab all these terms, like let's not like leave anything to be understood for the later on purpose. So let me know in the comment section about if you understood or if you didn't understood, if you have any queries about any terminologies that we have covered so far, and I'll keep you posted about what all terms are we going to cover in the next upcoming session. So that's all for today. The only request from your side is do support to subscribe and share so that we can have a good bunch of community. And with that mention, hope we'll see you in the next demonstration. Thank you.